Right, let's have a look at the hexadecimal number system. So we know that there are two values can be represented in binary, 1 and 0. Denary, 10 values, 0 to 9. Hexadecimal represents 16 different values, 0 to 9 and 10 to 15 represented by A to F. Binary numbers, which can be 1 or 0, we also call base 2 numbers. Denary numbers, 0 to 9, we also call base 10 numbers. So hexadecimal numbers we call base 16 numbers. Obviously 25 in denary is very different to 25 in hexadecimal, so that's how we can tell the difference. So how do we convert between binary and hexadecimal? Let's start with a nice simple 4-bit number. This number is in denary the number 2. So we look at our hexadecimal values. The number 2 in denary is also represented by 2 in hexadecimal. So this 4-bit number is 2 in hexadecimal. So if we have a look at a bit of a bigger number, this number in denary is 14. So we have to think about how is 14 represented in hexadecimal, and if we remember, that is represented by E. So this 4-bit number, its hexadecimal value is the letter E. Okay, for 8-bit numbers it's slightly different. We take the 8-bit number, the first thing you'll do is split it into two 4-bit numbers. You do exactly what you did before with those 4-bit numbers, converting them to denary. In this case will give you 4 for the left bit, and for the right hand bit it will give you a value of 10. You have to remember though, 10 is represented by A in hexadecimal, so the value is 4A. You won't be asked on your exam to convert 16-bit numbers, but it's very simple. You break the 16-bit number into 4 blocks of 4 bits each. You will then convert each of the 4 blocks of bits into the denary value as before. We'd convert any numbers that are represented by letters into the letters. Then you simply would combine the 4 together to get your hexadecimal value. So how do we convert from denary to hexadecimal? If you take a denary number like this example 214, you should know that the maximum value an 8-bit number can hold is 255, so it will be an 8-bit number. Write it down in binary, split it into 2 blocks of 4 bits, convert those blocks of 4 bits to denary. Remember, in this example 13 will not be represented by 13, it will be represented by D. We join them together and there is your hexadecimal representation of 214. Why do we use hexadecimal then? We use it because if you have a look at this denary value, it's a fairly big number. If you convert that to binary, you're going to get a huge number. Now the hexadecimal representation is actually a lot simpler, so we do use it really to simplify numbers. If you've ever used Photoshop or Fireworks, you've probably seen the colours represented in hexadecimal like this. If you convert that to denary, it's quite a complex number. Binary, it's even more complicated. They use hex to keep it simple. So what do you need to know for your exam? You make sure that you can convert 4-bit and 8-bit binary into hex and back, convert denary to hexadecimal and back, and understand why we use hexadecimal numbers.